Hi, I'm Ridul. I'm going to teach you how to solve problems using Newton's second law of motion by taking this example of a pulley wedge system. So consider this wedge that is smooth and fixed to the horizontal surface, and then there are two of these masses that are attached to this string that passes over a frictionless and a massless pulley. So our task is to find acceleration A of the system in terms of the masses, the gravitational field G, and the angle of inclination theta. So the approach to solving this problem is to always make a free body diagram of all the bodies involved and representing the forces by these vectors acting on each of these bodies. So the mass m1 has three distinct forces acting on it, that is the tension in the string, the normal reaction, and the gravitational force. Then we will distribute these forces in two perpendicular directions, that is along the incline and perpendicular to the inclined plane. For mass m2 there are only two forces acting on it, that is the gravitational force and the tension in the string. Now we'll just form the equations of motion using the Newton's second law of motion. The first equation is the normal reaction minus m1g cos theta, and that is equal to 0 because there is no acceleration considered in the direction perpendicular to the inclined plane. The second equation is the t minus m1g sine theta equals to m1a, that is along the inclined plane, and minus sign appears here because the forces are in opposite direction to each other. The third equation comes from the m2g minus t equal to m2a from the mass m2. So finally we can substitute the value of t here to the third equation in order to get the final result for the acceleration, that is m2 minus m1 sine theta g upon m1 plus m2. This expression also tells us that our assumption for the acceleration direction is only true when this is positive, which means m2 is greater than m1 sine theta, or else it will be negative. Thank you.